The purpose of this recording is to show you how to construct sequence diagram for e sub n equal to 1 plus 1 over n raised to the power n using mathcad, and then explore sequence from sequence diagram. As we know, the limit of 1 plus 1 over n raised to the power n is e as n goes to infinity. So we want to know for what value of n we will have 1 plus 1 over n raised to the power n less than e plus epsilon and greater than e minus epsilon. In particular, if epsilon is equal to 0.1, what are the possible value of n? Here is the sequence diagram. I have the red point here represent the an, and then two horizontal lines, one equal to e plus epsilon and e minus epsilon, and together they enclose a yellow band. From the sequence diagram, we know that at around n equal to 14, a sub n is lying between the yellow band. That means that a sub n is between e plus epsilon and e minus epsilon. For n greater than or equal to 14, we know that the absolute value of 1 plus 1 over n minus e will be less than 0.1 by exploring the sequence diagram. Now, how do we construct sequence diagram? The following video will show you. First, when I open up a mathcad document, a blank space, I entered n equal to 1 semicolon to 50. Then on the next line, I entered a sub n, subscript n, move to the right, equal to, open a bracket, 1 plus 1 over n, move out, close bracket, and then raise the power n. And I'm going to set epsilon. So I go to grid symbol and I go to select epsilon, shift equal to 0.1. Then I'm going to insert a graph. So I go insert graph, XY plot. Then I entered a sub n here, a subscript n, and then horizontal axis I entered n. Now I can format the graph. Let me resize the graph first a little bit so that you can see clearer. So I have resized the graph. And then I'm going to format the graph. Right click, format, under trace. Now I'm going to add a symbol instead of line. I'm going to add a cross. And okay, so the sequence diagram appear. Notice that the sequence 1 plus 1 over n raised to the power n tends to a limit, which is e actually. This diagram shows you that it is getting closer and closer to e. Then how do we add the two horizontal lines correspond to epsilon, where epsilon is equal to 0.1, plus epsilon, which is 0.1, and then after finish already, we can see that there is a horizontal line corresponding to e plus epsilon. Now we can also add another line, type comma again, then we type e power 1 minus 0.1. Then we can see the second horizontal line, which is in green. So we can find that around n equal to 14, for example, we will find that the value of an will fall between e plus 0.1 and e minus 0.1. Now, if we modify the sequence, say b sub n equal to 1 plus 1 over n raised to the power n plus 1, what will happen to the sequence? We know that limit of bn is still 1 plus 1 over n power n times 1 plus 1 over n, and you let n goes to infinity. By using the product rule, you know the first sequence tends to e, second sequence tends to 1, answer is still e. Now, it is interesting to look at how the sequence behave. Let's examine this using the sequence diagram again. Let's go to the sequence and change the power n to n plus 1. Then click. You'll be surprised. Now, the graph changes and is decreasing towards the number e as well. So, the challenge now is, can you prove algebraically that 1 plus 1 over n raised to power n is increasing and the limit is e, and 1 plus 1 over n raised to power n plus 1 is decreasing and decreasing to e. Thanks for watching. That's the end of the recording.